In this topic, we'll unpack how an X.509 certificate is structured, how certificate chains link back to trusted roots, and how Windows, browsers, and applications validate them. By the end, you'll understand exactly why that padlock appears, or doesn't. You've already seen why PKI exists and how certificate authorities anchor trust, along with the core cryptography tools, key pairs, hashes, and digital signatures. Now we'll shift to how those keys and identities become certificates, how chains are built, and how different systems decide whether to trust what they're seeing. An X.509 certificate is like a digital ID card for cryptography. It states, this public key belongs to this specific subject, whether that's a server, user, device, or service. A certificate authority vouches for that claim by signing the certificate and defines when it's valid and how it can be used. Applications then rely on the certificate to authenticate who they're talking to, encrypt data, and verify that nothing was tampered with. Digital certificates are basically ID cards with a few critical identity fields. The subject says who the certificate is for, like a website name, a user, or a device. The issuer shows which certificate authority actually signed and vouched for it. The serial number uniquely identifies that specific certificate for tracking or revocation, and the validity period defines when it's safe to trust the certificate and when it expires. Modern clients don't really rely on the old subject name anymore. They look at the subject alternative name and ask, does this exact identifier match what I'm connecting to? For HTTPS, the browser compares the requested hostname to the DNS entries in SAN. If you move a site from web01.contoso.com to portal.contoso.com and forget to add the new name to SAN, users will see certificate errors even though the certificate looks fine. Key usage answers. What cryptographic actions can this key perform? Things like creating digital signatures, encrypting keys, or signing other certificates. Enhanced key usage answers. What is this certificate actually for? Is it a web server cert, a client auth cert, a code signing cert, or used for secure email? CA certificates usually need certificate signing key usage, while end entity certs do not. If these settings don't match the intended purpose, applications will reject the certificate. A thumbprint is simply a hash of the entire certificate, not part of its official identity. If anything in the certificate changes, even a single bit, that hash changes too. Administrators rely on this for precise targeting. When two certificates share similar subjects or friendly names, their thumbprints will still be unique. Tools like MMC, PowerShell's getChildItem in the cert, drive, and certutil display thumbprints so scripts and bindings can reference the exact certificate. Under the hood, a digital certificate is just structured data plus a digital signature from the certificate authority. The CA takes the certificate data, computes a hash, and signs that hash using its private key. When a client receives the certificate, it recomputes the hash and verifies the signature with the CA's public key. If anything in the certificate data has changed, the hashes no longer match and signature verification fails. When your browser connects to a secure site, it doesn't just trust that server's certificate on its own. Instead, it walks a chain. At the top is a root CA, which your system already trusts. That root signs one or more intermediate CAs. Those intermediates then issue end entity certificates to servers, users, or devices. If the server's certificate can be linked, step by step, back to a trusted root, the connection is considered valid. When a client receives a certificate, it immediately tries to build a chain from that certificate up to a root it already trusts. First, it finds the issuer, then checks that each certificate is correctly signed by the next one up. At every step, it verifies dates, revocation status, CA flags, and extended key usages. Only if the chain ends in a trusted root does the certificate become acceptable. You can think of the certificate chain as three distinct roles. The root CA is the ultimate trust anchor. It's rarely used, but its certificate lives in trusted root stores. Intermediate CAs do the day-to-day signing, using CA extensions that allow them to issue further certificates. End entity certificates sit at the edge. They identify users, computers, or services, and must not be able to issue other certificates. Windows doesn't rely on a single trust list. It uses multiple certificate stores. The trusted root store contains the top-level CAs your system inherently trusts. Intermediate stores help Windows build complete chains from a leaf certificate up to a trusted root. Each machine has both a local computer store and per-user stores, which might not match. In a domain, Active Directory and group policy can centrally push trusted roots and intermediates to all joined systems. Here's the key idea. Trust isn't global, it's per application. Some apps, like Edge and Chrome on Windows, lean entirely on the Windows Certificate Store. If a root is trusted there, those apps are usually satisfied. Others, like certain browsers, Java applications, or custom clients, ship their own trust store and add extra checks. That's why a certificate can look perfect in one tool, but fail loudly in another. When a certificate isn't trusted, run a quick mental checklist. First, is the root CA actually installed in the trusted store? Next, is the chain complete, with all required intermediates? Then, verify the subject or SAN matches the hostname or service you're connecting to. Finally, confirm the certificate is within its validity dates and that key usage and EKU match the way the application is using it. Certificates are structured trust packages: identity, public key, usage rules, and a signature from a certificate authority. Systems validate them by building a chain to a trusted root and checking they're still valid and allowed for the task. In the next topic, we'll follow certificates through issuance, expiry, and revocation.